Good day. For those of you who do not know us, we're the instructional staff for ECE 150, Professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to have a quick summary of Section 1. So in this topic, we're going to review what we have covered so far, and we're going to look ahead to see what's coming up. Now, up to this point, you have seen the basics of programming. This includes literal data and types, including integers, floating point, characters, and Boolean types. We've also looked at identifiers, and from this, we developed local variables and arrays. Now, we also looked at arithmetic and logical operators, as well as assignment and auto-assignment operators, including the auto-increment and auto-decrement operators. To actually have running programs, we've described conditional and looping statements, including for loops and while loops, as well as the break statement. We've described functions and how we can pass information to functions through parameters, and how functions can return information through return values. We've described libraries and how you can use libraries with functions that someone else has authored. We've also seen the binary and hexadecimal representation of numbers, and the reason we do this specifically because in the computer is best equipped to store just 0 or 1, or as we saw, 0 volts or 5 volts. With a binary representation, we described bitwise and bit shift operators, and near the end we saw pass by value versus pass by reference and the const keyword. We've also looked at a few additional topics. The structured programming theorem that told us that all programs that can be written using only what we've seen up until this point, namely arithmetic and logical operators and conditional and looping statements. We also looked at some basic programming and code development strategies, which is beginning to touch on software engineering. This includes assertions, code skeletons, the authoring of tests, commenting your code, logging the execution of your code, and tracing the execution of your code. We've also described the structure of memory, including the idea that every single byte has its own address, and how programs, once compiled, can be loaded into memory and executed, resulting in a code segment that contains the instructions, a data segment that contains constants, including literal strings and perhaps large floating point numbers, and the call stack. Specifically, we looked at how the call stack can be used to allocate memory for both parameters and local variables of function calls. Finally, at the end, we started to see a data structure. So we actually used a character array to represent something we actually have in reality, namely the concept of a string, that is, a finite number of characters that represents something, hopefully in some sort of language. Alright, so now that we have discussed memory and addresses, we're going to use this a little bit more in the next topic. We're going to be looking at storing addresses in variables. Any local variables or parameters that store addresses are simply called pointers, and we will see how we can use pointers. Specifically, we will use addresses and pointers in the dynamic allocation of memory. You may remember that local variables and local arrays have their scope restricted to the function in which they are declared. We're now going to be able to allocate and use memory outside the scope of the function that it is declared in. That is, we will be able to have dynamic memory that allows us to share memory outside the scope of any one function. Once we have covered this topic, we will then start looking at algorithms. We're going to start by describing something called a sorted array, which you can almost figure out right now what it is. It's an array of either integer or floating point numbers where each subsequent entry is larger than the previous entry. We will describe searching algorithms on sorted arrays, and then we will look at sorting algorithms. Algorithms that can take an array that is not sorted and rearrange the entries so that they are. We will also describe recursive algorithms, that is, algorithms implemented as functions where those functions will call themselves by taking a larger problem, splitting the larger problem up into smaller problems, recursively solving those smaller problems, and recombining those solutions to create a global solution. Following this, we will then investigate classes and their features. Specifically, we will focus on linked lists. We will be contrasting linked lists with arrays for the storage and handling of data. So following this topic, you now have a brief review of what we have seen to this point. Basically, what are the mechanisms of authoring programs using specifically the C++ programming language. We've also covered some rudimentary topics related to software engineering. You also know what's coming up next: addresses, pointers, and dynamic memory allocation. And after that, we will be looking at algorithms, classes, and specifically linked lists. Here's the references, the colophon, and a disclaimer. Cheers!